Hello everyone, and welcome to Solving Rational Equations. Now, in the other videos that I've gone over, every single time I've just been simplifying the expression. Okay, there hasn't been any equal signs, and for all the work we've done, we've always had a fraction left over, a fraction with x's still involved. Now that we're solving, remember the main purpose of solving is that we're trying to get to x equals. That's what we're going for. We need at the end of the problem to have an x equals something. Okay, so as I look at my problem, I see I have three fractions, and I see two things. Number one, I'm adding a fraction on one side of the equation, so that immediately tells me that I will need eventually a common denominator in order to add these. But I can't forget the golden rule of equations is that what you do to one side of the equation, you must do to the other side of the equation. What that means is I've got to make sure that all three of these fractions have the same common denominator. Now the nice thing is they're all x squared. So the only thing left to multiply is a 3. That way they're all 3x squared. So multiply this first one by 3, the second one by 3. And please remember that when I multiply, I am multiplying to both the numerator and the denominator. Okay, and here we go. Let's erase that. So now I have 6 3x squared, 1 over 3x squared, plus 3 times 2x minus 5 over 3x squared. Okay, so now that everything's over a common denominator, I can go ahead and I can add those two fractions. And I'm going to distribute. So that will be 6x minus 15 over there, all over 3x squared. I'm going to continue combining like terms in my numerator, and I have 6x minus 14 over 3x squared. Okay, now currently I have a fraction, and I need to get x on one side of the equation. Flashback to last semester, last year, actually the beginning of the year, when we talked about how in order to get rid of a fraction, you multiply by the denominator. Because multiplying by the denominator would cancel out the denominator. Alright, even though it looks a little weird, this rule still applies, and the nice thing is when we cancel out our denominators, it cancels out on both sides, and we are left with a much simpler equation. Okay, add 14 to both sides. 20 is equal to 6x. Okay, and we get that 10 over 3 is equal to x. Let's go on to the next one. Alright, in this one, I'm looking across my denominators. I see I have some a squares, and I really only need to multiply by this middle fraction, multiply by an a, in order to make sure I have a common denominator across the board. So, don't need to do much at first. 2a over a squared minus 5 over a squared. Now I have common denominators, so I'm going to combine like terms on one side of the equal sign. And now that I have a fraction is equal to a fraction, I'm going to go ahead and multiply both sides by a squared to cancel out my denominator. And now I have a plus 6 is equal to 2a minus 5. Add 5 to both sides and subtract a, and I get 11 is equal to a. Okay. So all of these skills are skills we've done before. You just got to use them together. Here we go. Next few. Looking across my denominators, I see x squares and I see 2x squares. So I'm only going to have to multiply this first fraction by a 2 in order to get my 2x squared in this denominator. So 2x minus 1 over 2x squared minus 1 over 2x squared is equal to 3 over 2x squared. Okay, I'm going to distribute and combine like terms. Keep your eye on the negative sign. Do not lose it. It should be a 2 minus 1 over 2x squared is equal to 2 over 2x squared. Okay, I'm going to go ahead and multiply by my denominator to cancel out the fraction. And that goes away, that goes away. I'm left with 2x minus 2 minus 1 is equal to 2. And now it's just a simple matter of combining like terms. My answer is x is equal to 5 over 2. Let's go on to the next one. Now on this one, I'm looking at my denominators and I see expressions. So what I'm going to do is before I try to get a common denominator, I'm going to factor out my denominators. And hopefully I don't have to multiply by a whole lot in order to get a common denominator. And I see that I have b times b minus 4, which means the only thing I have to multiply to this last fraction is b minus 4, which is nice. Please make sure your handwriting stays neat. The b's can sometimes look like 6s if you're not careful, as I just showed. Okay, so we have b minus 4 in this numerator, and now I have b times b minus 4 in the denominator. Combine like terms. All right, and now I'm going to multiply by my denominator in order to cancel it out. And everything goes away. And now I have 6 is equal to 2 plus b minus 4. Continue to combine like terms. And you get that 8 is equal to b. All right, last two problems. As I'm looking across my fractions, I see a lot of common terms. So I'm going to factor out my denominators to see if my life will be a little easier this round. Okay, I'm going to change colors just because. Now I have 6 over m minus 5. Okay, and I do have a common denominator of sorts. I see a lot of m minus 5s. So I got to multiply this first fraction by m minus 5. Please remember it goes to both the numerator and the denominator. And I now have common denominators across the whole board. Now I'm going to combine like terms. Keep an eye on this negative sign. And the reason why I keep stressing that is because sometimes you'll have a binomial as that second term, and then you're going to have to distribute that negative sign. If you're not careful, the negative sign sometimes doesn't go all the way, and then you end up getting the wrong answer. So whenever you have a negative sign in between your two fractions, always pay special attention and make sure you don't have to distribute. Or if you do, that it goes to every single term. Multiply by my denominator to cancel out the fractions. And we have now a simple equation. There we go. Last but not least, as you can kind of see, this is already a very similar problem to the last two. So the video is going to pause, see if you can handle this one. When it plays again, you'll see my answer. And here's my answer. Does your answer match mine? Okay, now in this one, very similar to the last several, factor out your denominators a bit. That way you don't have to multiply by more than you need. And then just be very careful when you're distributing. Alright, if you're using my notation where I only write what I'm multiplying by, please make sure you remember it goes to the numerator and the denominator. Okay, if you're not careful, sometimes it only goes to one and not the other, and that will throw your answer off. Okay, let me know if you have any questions, and I'll see you next time.